For Monday, April 14, 2025, a 15% probability of severe weather has been outlined by the Storm Prediction Center across portions of the Ohio Valley, including western Pennsylvania, northern West Virginia, southeastern Ohio, northern Kentucky, as well as southeastern Indiana. This conditional severe weather threat is being modulated by an amplifying synoptic scale pattern characterized by a deepening mid to upper level trough over the upper Midwest and a developing surface cyclone tracking northeast into the Ontario Quebec border region. Further amplification of a broadening mid to upper level trough and attendant surface cyclone is expected across the upper Great Lakes to the southern Ontario Quebec border area. Poleward moisture quality from the western Gulf will remain suboptimal but will continue to improve beneath a lobe of the southern Great Plains elevated mix layer. The northeast extent of weak surface buoyancy should overspread the Ohio Valley by Monday afternoon. This portion of the front will coincide with a robust 7 to 500 millibar southwesterlies yielding potential for fast-moving convection. Guidance consensus suggests this will remain the favored corridor for at least a damaging wind threat. Embedded within the synoptic wave is a belt of strengthening mid-level flow with 50 to 60 knot southwesterlies traversing the lower Great Lakes and Ohio Valley. This will overlay a developing warm sector where insulation, despite modest surface dew points, is expected to promote weak surface-based destabilization. The 12Z model sounding from Pittsburgh reveals several parameters supportive of low-end severe potential, particularly in the form of transient supercells or short-lived QLCS segments capable of producing strong wind gusts and possibly a brief tornado. Let's take a look at the thermodynamic profile first. Let's look at the surface CAPE. CAPE stands for convective available potential energy. This measures the amount of energy available to a parcel of air to rise freely. And what we're looking at here, if you can see that yellow arrow, we have 565 joules per kilogram. This is modest instability, enough for showers and isolated thunderstorms, but it's below the 1,000 to 2,000 joules per kilogram range typically needed for strong to severe storms. This is marginal potential for updrafts, but not explosive storm growth. This could support weak to moderate convection, particularly if other dynamics are favorable. Moving on to the LCL height. LCL is the cloud base height important for tornado and low level visibility. Currently, the model is showing 400 meters. 400 meters is very low. This supports efficient low level stretching and moisture condensation. This enhances tornado potential, efficient rainfall, and storm aesthetics, which means low cloud bases often make storms more photogenic and ominous. Moving on to the LFC height, the LFC is the level where the parcel becomes buoyant and accelerates upward. The model is showing 3,478 meters. This is around 3.4 kilometers. It's pretty high for spring setups. Storms may struggle to gain initial momentum unless forced. This requires a lifting mechanism, for example, fronts or outflow boundaries, to help air parcels overcome the initial layer. Moving on to the EL height, EL stands for equilibrium level. That's the top of the thunderstorm's vertical reach. So far, the model is showing at around 10,872 meters or 10.8 kilometers. This is around 35,000 feet, supportive of deep convection and lightning. If storms develop, they could reach mature thunderstorm heights, favoring organized convection if shear is sufficient. Taking a look at the moisture and rain potential, let's look at precipitable water. PW measures the total atmospheric moisture. The model is showing 1.27 inches. This is above average for April in Pittsburgh. It indicates a moist column and potential for heavy rain. Any storms that form could produce efficient rainfall, increasing the flooding or ponding threat, especially if the storms are slow moving. Moving on to the downdraft and cold pole dynamics, let's take a look at DCAPE. DCAPE stands for downdraft cape. It indicates the strength of potential downdrafts. We're looking at 476 joules per kilogram. This is less than 600 joules per kilogram, which is modest potential for downdraft driven wind. Marginal threat for strong wind gusts, most likely here, especially in pulse thunderstorms. Moving on to surface conditions and triggering, the surface dew point and the temperature. We're looking at 65-degree temperature with a 60-degree dew point. This indicates warm, moist surface air contributes to instability. Looks like we have a narrow spread, high humidity, and low cloud bases. This is a good environment for storm initiation if the convective temperature is reached. Since I mentioned convective temperature, this is the temperature needed to start convection. The model is showing 72 degree Fahrenheit. which means we're 7 degrees away. We would need moderate surface heating to initiate storms by mid to late afternoon. If the sun breaks through or there's enough forcing, storms will be likely. Let's take a look at stability indices. First, we'll start with the K index. The K index assesses thunderstorm potential. The model is showing 34 for this value. This indicates that thunderstorms are possible and that they will be scattered. And the implications of this are conditions are supportive of general convection. Just below the K index there, we're going to look at the TT index, or the total totals index. This looks at lapse rates and moisture for thunderstorm intensity. The value here is 53. The interpretation of this is that it's greater than 50, which means severe thunderstorms are possible. Combine this with shear, this could support stronger cells and maybe even a rotating storm. Moving on to shear and storm rotation, we're going to look at the surface to 1 kilometer EHI, which stands for Energy Helicity Index. This measures the instability and the low-level helicity to check for tornado potential. The interpretation of this is near 1, so the value is 0.9. This means that a low-end tornado threat is possible. Higher values of 1.5 or greater are more favorable. 0.9 is not 0. And especially with the low LCL, a brief spin-up cannot be rolled out. Moving on to the effective inflow, this is the shear in the layer feeding the storm. Our value here is 355 meters squared per second squared, which is greater than 300, which means this is quite strong. The implication of this is that rotating updrafts are possible. This is a favorable tornado and shear environment, even if the cape is modest, which we have. We only have 565 joules per kilogram, which is modest cape. Taking a look at the surface to 1 kilometer SRH, this is the low-level directional wind shear. Our value is 252 meters squared per second squared, which is greater than 200, which means this environment is favorable for mesocyclones. The implication of this is low-level winds can organize storms and support rotation. Taking a look at the BRN shear, this is bulk shear useful for distinguishing multicellular storms versus supercells. Our value here is 112 meters squared per second squared. The interpretation of this is it is between 40 and 150, which supports supercells or strong multicells. The implication of this is that the environment will support organized updrafts. Taking a look at the critical angle, this is the angle between storm inflow and shear vector. Our value is 47 degrees, which is greater than 45 degrees, thus we have an enhanced tornado genesis potential. The implication of this is we have a favorable orientation for tornadic storms if the instability can improve. Moving on to supercell and tornado parameters. First, let's look at supercell composite. This is a composite of cape plus shear and helicity. Our value is 4, which is greater than 1, which means the potential for a low-end supercell is possible. The implication of this is that we could see transient supercells or organized multicellular clusters. Just below that, we will see the STP, which is SIN adjusted. This stands for the significant tornado parameter. Our value here is 0.8, which is less than 1. If this can go above 1, it will be concerning. Unfortunately, right now, or fortunately, whatever way you look at it, our value is 0.8, which is near a marginal threat for tornadoes. The implication of this is that the environment is close to supportive for tornadoes, so we're definitely going to have to watch the trends. Taking a look at high-level instability, we're going to look at 3 CAPE. This is the convective available potential energy in the mid to upper troposphere. Our value is 3 joules per kilogram. This is very low, and the implication of this is limited elevated instability, which means storms are likely to be surface-based, not elevated. Despite modest CAPE of 565 joules per kilogram, the environment is conditionally favorable for organized thunderstorms, possibly rotating if storms initiate. Strong low-level shear, a moist atmosphere, low cloud bases, and weak capping support storm formation with damaging wind threat and a low but non-zero tornado threat, especially if any supercells develop along a boundary. The key concerns are if the surface temperatures can reach the convective threshold of 72 degrees Fahrenheit, especially with a frontal lift or upper level support, scattered storms may rapidly develop. The SRH values of 355 and 252 are quite high, which means any updrafts that can stretch vertically could rotate. The bottom line, folks, is while this is not a high-end setup, this is a watch the radar closely day. If surface temperatures climb into the low 70s and storms develop along a boundary or outflow, localized severe weather including damaging winds, isolated hail, and even a brief tornado is on the table for Pittsburgh and the surrounding Ohio Valley region on Monday, April 14, 2025. If you found this analysis helpful, Don't forget to like the video and subscribe to the channel so you never miss a forecast. And if you feel inclined to support what I do, there's a donation link to my PayPal in the video description below. Every bit helps to keep this content going strong. Stay weather aware, stay sharp, and as always, I'll be here keeping a watch on the skies.